All right, example 4. Here is a situation where your first term given is called term 1, not 0. So writing the explicit rule will be a little different. So definitely make a note of this. And what you want to write is you're going to do f of n equals the first term you're given, so term 1, not term 0, plus your common difference times one step less, one step number back. So this would be term 1, not 0. This is the common difference, which is your pattern in an arithmetic sequence. And then just n minus 1, which is one step number previous. All right. So when we write the explicit rule, I'm going to use that formula I just showed you. And this is term 1. Well, what's term 1? It is 12. And then what is our common difference? Remember, it's the pattern. You're subtracting 3 every time from the previous term, so it's going to be minus 3 times n minus 1. And that works every time. Even if you're given f of 0, you can use this rule or formula. All right, so then now we can clean this up a little bit and we can distribute here Be careful with your distributive property. You are distributing a negative 3. We can add some like terms here. And we're going to get f of n equals, we'll put negative 3 in front, just for formality. If you don't, it's okay. Plus 15, because those were the like terms. And now we've come up with our explicit rule. Please notice how our common difference still ends up in the slope spot, the coefficient of the variable, that rate of change. But notice that the number given initially doesn't match this, because this wasn't the 0 term or the y-intercept. So we had to do a little bit of cleaning up to get to this. Don't forget to write your bounds. So it will be n is greater than or equal to 2. If you put 1, that's okay. But because we were given the first term, we look at the next term on. All right. Definitely make a note of this in your notes. Label what each part means. And show your work, because you're going to want to know this process for the practice quiz. All right. Example 4. Find the common difference, explicit formula, and 22nd term in the sequence. So take a moment and write down that you're going to find all of this. All right. So we know our first term. So a sub 1 is 11, or the first term. We need to identify our common difference here, and clearly every time we are adding 200. So D for common difference is 200. And just like in example 4, because it wasn't defined as step 0, this is always going to automatically assume to be step 1. If we don't know step 0, like we didn't in example 4, we're going to use this relationship to write the explicit formula. Why do we need the explicit formula? So we can find the 22nd term. Otherwise, we're sitting here for quite a while trying to write out this pattern. The explicit form always allows you to find any term. Remember, we wrote that in the beginning of your notes. The explicit function always allows you to calculate any term without knowing the previous one. All right, so f of n equals our first term 11, first term that we know, I should say, plus a common difference. It's positive because the common difference was increasing. Up here it was decreasing, so you'll notice how it was negative, times n minus 1. So I'm just following this rule again. Boom, right? Okay, so then f of n equals 11 plus 200n minus 200. So just being careful with my distributive property. Now we're going to combine like terms. So remember that that minus sign in front of the 200 makes it negative. So you're doing 11 minus 200. And so you're going to have, we're going to bring this term down, 200n minus, so putting these like terms together, 189. Alright, so we've done common difference, we've done the explicit formula, so common difference, explicit formula. Now we need to find the 22nd term. So f of 22 equals 222, we're plugging in 22, minus 189. So we're going to calculate that real quick. And we get 4,000, f of 22, the 22nd step in this sequence, so make sure you know how to read the function notation, is 4,211. Make sure you're pausing these videos and replaying them and backing them up when you hear something that you're not sure of. So, there you go. Alright, example 6 says find the first 4 terms in the geometric sequence. So the last couple examples have been arithmetic. Alright, so this is our first term here, and this is our common difference. So because they told us geometric, we need to remember that this is multiplication. Alright, so our first term would be 1.5, and then we're multiplying by 2, so that's going to be 3 times 2, 6 times 2, 12. And those would be the first 4 terms in this sequence. And that's all you had to do for that. So if you ever see this and it's given geometric, you've got to remember it's multiplication. If they don't tell you that, but they're referring to common difference, that's going to be arithmetic. Almost always common difference is used with arithmetic.